Welcome. In this session, we'll continue with phasor analysis. So let's consider one more example. Let's consider a series RC circuit. Series RC circuit connected to a voltage source. V of t is suppose 500 cosine of 10t. Okay. Now let's assume the resistance is 6 ohm and the impedance offered by the capacitor. Will not write it in terms of G divided by omega C. Let's assume the impedance offered by this is simply minus J times 8 ohm. Okay, and our goal is to find what is the current flowing in this circuit. So our goal is find I of t, okay, and also find Z. That is the impedance offered by this circuit. Okay, let's start with. So what we'll do, we'll convert this in the phasor domain. Although we are already given the impedance offered by the capacitor, we'll convert this source that is given in time domain first into the phasor representation. So R will be replaced by simply 6. Capacitor impedance is already given in phasor form. So we'll write it minus 8J and simply we'll replace the source voltage, that is 500 at an angle of 0. Why 0? Because phase is 0. Then instead of I of t, we'll write I phasor that we need to find. So again, this is a series circuit. So we'll apply KVL. We have 3 elements here. So we'll sum the 3 branch voltages to 0. So applying KVL in this loop. And let's suppose we start with this. So what we encounter first in this path, minus 500 at an angle of 0 plus the voltage drop in resistor will be 6 times I. 6 is the impedance multiplied by current is the voltage drop. Similarly, then I multiplied by minus 8J is the voltage drop in this capacitor. And sum of these voltage drops is equal to 0. Now, to find I, we'll write this equation as 6 minus 8J times I will be equal to 500 at an angle of 0. Now from this step onwards, it's simply complex algebra. So if you know how to manipulate complex numbers, you will be able to find I phasor. So this will be 6 minus 8J. Now 1 is given in rectangle form, the denominator is given in polar form. So this rectangle form, let's convert, sorry, this is 500. So this will be 500 at an angle of 0 divided by under root of 6 square plus 8 square. That will be equal to under root of 100. Under root of 100 is 10 at an angle of tan inverse minus 8 by 6. That's minus 53.13 degrees. So 500 divided by 10 is 50. 0 minus 53 is plus 53, right? You know how to manipulate the complex numbers. So this is the I phasor. This is the phasor current flowing in the circuit. But if we have to write the I of t will be simply equal to 50 cosine of, what is the frequency? Frequency is 10t plus 53.13 degrees. So this is the current. right? So this is the current flowing in the circuit. Now to find Z. So in order to find Z, what we'll do, we'll divide the V phasor with I phasor. So V phasor is 500 at an angle of 0 divided by I phasor is 50 at an angle of 53.13 degrees. So if you simplify this, 500 divided by 50 is 10 at an angle of minus 53.13. Why? Because it will be 0 minus 53.13. So this you can write as, this is given in polar form. In rectangle form, we can write it as 10 cosine of minus 53.13 degrees plus J 10 sine minus 53.13 degrees. So cosine 53.13 is multiplied by 10. It will be simply equal to 6 minus 10 sine 53.13 will be minus 8G. So this is the Z. So this is the impedance offered by this circuit, and this is the current flowing in this circuit here. Okay, this is in amperes, and this will be in ohms. All right, now we already know the impedance of this circuit because this is connect, the two elements are connected in series, so the total impedance will be simply 6 plus minus 8G, right? That is 6 minus 8G. Impedances add in series. So the total impedance will be this impedance plus this impedance. Since one is complex, so it will be 6 minus 8. We already knew this, but we verified it using V and I relationships. Okay. In the next session, we will continue with the examples.